All right, guys, here we go. Finishing up the notes for Chapter 3, and we're going to start this discussion with talking about analog versus digital consoles. You can think of a digital audio console as a fairly flexible hybrid computer workstation with many possible input and output capabilities. The console that we have in Production B is an example of a digital console. Some of the distinctions of a digital console include being able to make use of analog to digital and digital to analog converters. So it provides for more flexibility, especially with certain types of digital equipment. Faders can be programmed to numerous inputs and outputs with flexibility of the layout of elements. You're not necessarily tied into, for example, the microphone being the first fader. You can, on most digital boards, pretty much set up your board so that you can control whatever element you want to control with whatever particular fader that you want to control it with. You have the ability to automatically start or stop play of certain input devices depending on the connectivity, and you have the ability to send digital output to various devices to be able to have prevention of the loss of generations of audio so that you're able to keep the integrity of the original sound a lot better. Regardless of the equipment that you have hooked up to the console or the kind of production that is being done, you are still going to be doing the three basic operations through use of the board, and that is amplification, routing, and mixing. Whether you have an analog board, a digital board, whatever, that is still your primary function: amplification, routing, and mixing. So as you're doing this, you have three primary concerns. First off, finding the various signal input sources on the console. In other words, answering the question, what channel fader controls which device? How do you bring up and down the volume of the CD player? How do you bring up and down the volume of the different microphones in the studio? Knowing where to go for those things. Second, writing the levels properly. In other words, using the VU meter, making sure that you have proper volume and loudness going out over the air. And this is so that you can also avoid distortion or muddiness. Make sure you're in that sweet spot, as close to 0 VU as you possibly can be without going over. Being as close to 100% modulation as you can be without going over. And then understanding the signal path. In other words, knowing how to get your selected audio inputs to the desired audio output. Is what you're playing something that you want going out over the air? Is it something that you want to monitor and listen to before putting it out over the air? Is it something that you want to record to a computer or a tape deck? Is it something that if you have a phone caller listening, you want them to be able to hear what's going on? So understanding how the audio is being routed, understanding the signal path. Many modern consoles provide a useful feature that allows the operator to put telephone conversations on the air without getting feedback when the announcer's mic is open. And this feature is called a Mixminus. Now, I'm going to be honest with you. In any radio studio that I've worked in, I've not seen this feature used very well. There could be a number of reasons for that. But generally, what the idea is here is that the board is going to be set up in such a way that you can have the telephone caller up and on while also having your microphone up and on, and you're not going to get any feedback sort of issues. In some studios, what they do instead is that they will have the telephone set up to be able to hear from a certain output other than program. And then you'll do some manipulation on the board to make sure the caller can hear you when you're talking to them. But if you have a board that successfully uses the Mixminus feature, basically what happens is that the board is going to take all the different signals that are being used that you want the caller to be able to hear, and makes it so that they're able to hear without that feedback happening. So this is one case where you're going to want to know your board and know how to interface with callers whenever you bring them in on the board. Digital virtual consoles. These provide flexibility for audio recording and production by allowing various sources and sometimes various audio effects to a virtual fader. Some of the advantages of this: it's easy to assign sources to various faders, and settings can be stored by the computer for later recall or changed on the fly. This is especially helpful if you have several different producers working within a studio and there's different requirements. Maybe there's a talk show that's going on and you only need to have certain elements available. Or perhaps there's settings for the morning drive show that's different from the afternoon drive show. And these digital consoles allow you to be able to program the board in such a way that it's most convenient to be able to work in that particular environment to meet the needs of that particular show or production. Some other advantages: you can try different arrangements to your heart's content. With a virtual console, you can stack the different takes of the voiceover and you can click on each take in sequence. Also, special effects are often built into the software, making expensive external hardware unnecessary. So a lot of times in studios, you may have a separate device that acts as a limiter and compressor, for example. You may have another device that acts as an equalizer, changing the highs and mids and lows on microphones. But in the case of certain virtual consoles, it allows for some of those different effects to be able to be programmed in and produced through the board itself. Now, some advantages of using what the book calls a real console, or using a typical analog console. The fading of several sources in real time is usually easier because, if you're someone that thinks visually in time and space, you can look and say, you've got the 3 microphones on your first 3 sliders, and you've got different elements throughout the board, and you can just physically go and do what it is that you need to do at that particular time. Also, a real console stays static. It's always there. It's always in the same position, the same perspective. In other words, you know that the microphones are always on the left-hand side. You know that the CD players are on the middle sliders or on the last sliders or wherever they may happen to be. So there's not necessarily having to think about, okay, what is the setup at this particular point in time? The setup's always going to be the same because the setup is the setup. So there's that. Now, some other devices that you may encounter include submixers. Submixer is basically just a miniature console that combines or gangs together a group of inputs. Many times you will find this, especially if you have a situation where you've got multiple microphones. Say perhaps there's a separate studio where the guests and the talk show hosts are sitting in, and all of the microphones that are being used by all of those people are being brought in, and you mix them on a submixer, and then the output of that submixer goes to a particular fader on the console. There's other situations where you may use a submixer as well, especially if you have a studio where there's just a lot of different elements that are going on and you need that versatility. So that is something that you may encounter. Routers and patch bays. Let's talk about what patching is. Patching allows you to route a signal in a way different from that the board was originally designed to do. And there are some applications where this may be necessary. Say you have a special case where you need to bring audio in from a different studio and put it out over the air, and the studios were not originally designed for that studio to be able to transmit its signal to the studio that you're working in. Patching would allow for such an operation to happen. There's two ways to change the routing of an audio signal. The most common way is to use a routing switcher. This is the device that makes connections between the console and its input and output sources at the touch of a button. You see an example on the screen there. That's the top picture there. So basically, you can say that you want the microphone of the production studio, for example, and have that set as an input, and then have the output set up as a particular fader in the main studio that you're working in. You can have a satellite source brought up as an input and have it set up to be on a certain fader. You could have different elements just be set up to go directly to your program out and go straight to the transmitter. Depending on how the routing switcher is set up, there's a lot of versatility as to the different inputs and outputs where you can receive and send audio. The second way is to use a mechanical patch bay. Sometimes it's called a patch panel. You see an example of that on the lower picture in your screen. Kind of looks like the old school Ma Bell telephone operator where they would patch calls from one call to another, and it's not completely different from that. It's basically just a physical representation of how to send audio from one place to another. So basically, it performs those kinds of functions. You take a 1/4-inch plug, you plug one end in to the source, you plug the other end in to its destination. And the cord, we call it a patch cord. It's a 1/4-inch cord. Close examination of a patch bay will reveal that the outputs and inputs that normally match up are going to be in line vertically. So where you've got the different holes for the 1/4-inch plug to be able to go into, normally you're going to have, say for example, a bank of audio sources on the top of the top row of the patch bay. And then below that will be various outputs where you're going to send the audio to. So if you have a certain audio source in, say, the first position on the patch bay, on the very top left of it, and then directly below that you have a certain output or destination, you can, without using any sort of patch cords, leave that in place, and that would be what's called a normal connection. That audio source would normally go to whatever the destination is that is directly below that. But when you change the arrangement by using a patch cord, that's called breaking normal. Now, you're going to find these situations in studios where they don't have a lot of digital equipment, where they still need to have the versatility of being able to connect several different studios or several different sources of audio, where for whatever reason it may not be practical to have dedicated faders for all of those things. And that's something that you may encounter. Generally, if you're in a situation like that, that's something that you're going to be in conference with the engineers at the station on, in terms of how to work those sorts of things. So with that, we're going to finish up the chapter. Get the study questions done, get the notes done, get them turned in, do the survey. Let me know what you think. Let me know what questions you have. Again, it's kind of tough in this situation because we're talking about a lot of different physical types of equipment and different scenarios that you might encounter. It may make more sense once you actually see things personally and try to get a sense of understanding of those things. But nevertheless, feel free to bring your questions and your comments when we get together in class, and we will try to help you make sense of it all.